In 1990, Honda built a supercar with an all-aluminum chassis, titanium connecting rods, and suspension geometry developed with direct input from Ayrton Senna. They sold it with a 3-year manufacturer's warranty, a functioning air conditioning system, and enough day-to-day reliability that an owner could drive it to work on Monday and take it to a track day on Saturday without choosing between the two. Ferrari's internal response, according to people inside the company at the time, was to immediately begin improving their own cars. A Japanese manufacturer had forced the benchmark to move. 8 cars, roughly a 12-year window, 1 country. Here is what Japan built. Number 1. 1990 Honda NSX. To understand what the NSX actually represented, you first have to understand what a supercar was. By definition, in 1989, the year Honda unveiled it to the world at the Chicago Motor Show. At that point in automotive history, European supercars operated under an unspoken agreement with the market. They were fast, they were exotic, and they were also frequently unreliable, expensive to maintain, and physically demanding to drive anywhere near their limits. Difficulty wasn't considered a flaw in that segment, it was considered part of the price of admission. Owning one meant accepting compromise as a condition of ownership. Nobody questioned that arrangement. It had simply always been true. Honda's engineering division looked at that arrangement after 6 years of development work and concluded it was fundamentally wrong. A supercar did not need to punish its owner to earn the title. The development process backing that belief was extensive. Honda ran prototype testing sessions at Suzuka Circuit with Ayrton Senna behind the wheel, and this was not a marketing arrangement or a photo opportunity. Senna drove actual development prototypes and gave specific technical feedback on handling characteristics. Honda's engineers took that feedback and used it to correct the car's suspension geometry before the car ever reached production. That level of direct, technical driver input from arguably the greatest driver of his generation is not something any competitor at the time could claim. The engineering itself broke new ground independent of Senna's involvement. The NSX was the first production car in the world to use an all-aluminum monocoque chassis and body structure, not aluminum body panels over a steel frame, but the entire structural architecture built from aluminum. That decision saved approximately 200 kilograms compared to what an equivalent steel structure would have weighed. Honda didn't use that weight saving to simply chase the lightest possible car on paper. They used it to achieve a genuinely competitive power-to-weight ratio from an engine that, by supercar standards, looked almost modest. A naturally aspirated 3.0-liter V6 producing 270 horsepower. On paper, that number doesn't compete with contemporary Ferraris and Lamborghinis. In practice, paired with a total curb weight of just over 1,380 kilograms, it was entirely sufficient, and it came with a level of drivability nothing else in the segment offered. The aluminum extended past the monocoque. The suspension components, front and rear, were also aluminum, saving an additional 20 kilograms over steel equivalents and contributing directly to a handling precision that road testers of the era consistently singled out as remarkable, composed, communicative, and confidence, inspiring in a way European exotics of the same period were not. Under the hood, Honda's VTEC variable valve timing system did something no mainstream engine had done before at this level of refinement. It physically altered camshaft profiles depending on engine speed, delivering smooth, tractable behavior at low RPM and a completely different character, sharp, high-revving, aggressive once the engine climbed into its upper range. The broader industry would go on to adopt variations of this variable valve timing concept for decades afterward. And then there's the endorsement that matters more than any marketing campaign could have produced. Gordon Murray, the man who designed the McLaren F1, a car still regarded by most of the industry as the finest road car ever built, has stated directly that the NSX was a foundational inspiration for that project. That is the most specific, most credible endorsement available anywhere in the automotive world, coming from the one person whose opinion on supercar design carries the most institutional weight. The NSX was sold in the United States under Honda's Acura brand, and it came with something no comparable European exotic offered at the time: a full manufacturer's warranty, backed by ordinary Honda dealership infrastructure. It remained in production for 15 years, until 2005, without requiring a fundamental redesign because the architecture Honda built in 1990 was already correct. It didn't need fixing. It needed time for the rest of the industry to catch up to it. Number 2. 1989 Nissan Skyline GT-R R32. Nissan launched the R32 Skyline GT-R in 1989 under an internal engineering initiative called Project 901. The stated objective of that program was explicit and ambitious on paper: make Nissan the world leader in dynamic vehicle performance by 1990. The GT-R was the most complete expression of that mandate the company produced. It arrived carrying two systems that, at the time, had essentially no parallel in any production car at any price point in the world. The first was a Tesla ET's, an electronically controlled all-wheel drive system built around a genuinely clever operating philosophy. Under normal driving conditions, the car behaved as a rear-wheel drive vehicle. Only when the rear wheels began losing traction did the system transfer torque forward to the front axle, and it did this continuously and instantaneously, reading sensor input from all four wheels in real time. The result was a car that felt engaging and direct like a traditional rear-drive sports car during normal driving, but that could call on the grip and stability of all-wheel drive the instant conditions demanded it. Nobody else was doing this in a production car. The second system was Super Heika's four-wheel steering that turned the rear wheels in the same direction as the front wheels at higher speeds, improving stability during lane changes and through sustained high-speed cornering. Combined, these two systems gave the R32 a level of dynamic capability that significantly outran what its official power figure suggested was possible. That official number, 276 horsepower, existed because of a voluntary agreement among Japanese manufacturers to cap published output figures regardless of what the engine actually produced. The RB26DE T-twin turbocharged inline-6 under the hood made considerably more than that number implied, and everyone in the industry at the time understood this. The GT-R didn't just perform well in competition. It dominated it in a way that forced governing bodies to intervene. It entered the Japanese Touring Car Championship in 1990 and won every single race it entered from 1990 through 1993, 29 consecutive victories. Officials responded first by imposing success ballast to slow it down, and eventually by drafting entirely new regulations aimed at keeping other manufacturers competitive. Australian touring car racing took the more direct route. It banned the R32 from competition outright. It was the Australian press that gave the car the name that has followed the GT-R lineage ever since Godzilla. Beyond the racetrack, tuners quickly discovered that the RB26DETT responded to modification in a way that produced power figures previously associated only with purpose-built racing engines, not showroom production cars. That reputation for near-limitless tuning headroom became a core part of the GT-R legend, independent of anything Nissan did at the factory. The R32 established the Skyline GT-R nameplate has the definitive proof of what Japanese engineering could achieve when given an ambitious brief and the resources to execute it. Without compromise or reputation, the GT-R name still trades on today. If this kind of breakdown is what you come here for, now's a good time to hit that subscribe button. We're only halfway through this list, and it gets more interesting from here. Drop a comment telling me which of these two cars you'd take first. Let's keep going. Number 3. 1991 Mazda RX-7 FD. Mazda had been building cars around the Wankel rotary engine since 1967, a full 24 years before the FD's launch, and at a point when every other manufacturer that had seriously investigated rotary technology had already walked away from it, concluding it was too complex, too fuel-thirsty, or too mechanically demanding to be commercially viable at scale. Mazda committed to it anyway, and kept developing the concept for 35 uninterrupted years. The third-generation RX-7, introduced for the 1992 model year in export markets, was the most fully realized expression of what that commitment could produce in a road car. At the heart of it was the 13B-RU twin-rotor engine, running two sequential turbochargers rather than a single unit or twin parallel turbos. A smaller turbo spooled quickly at low RPM to eliminate the lag that plagued larger turbocharged engines of the era and delivered immediate throttle response. A larger turbo then came online at higher engine speeds to sustain strong top-end power once the smaller unit had done its job. The combined output was 255 horsepower from just 1.3 liters of displacement. No conventional piston engine in production anywhere in 1991 produced that kind of output from that little displacement in a road-going car. It wasn't close. What made the rotary distinctive wasn't just the power figure, though. It was the character. With no reciprocating pistons and no traditional valve train, the 13B roue delivered power that felt continuous rather than pulsed a smoothness genuinely unlike any other engine format in production at the time or since. Mazda built a chassis around that engine weighing just 1,260 kilograms, and through careful placement of every major mechanical component, achieved a front-to-rear weight distribution of exactly 50-50, the kind of balanced chassis engineers spend entire careers chasing. The body wrapping all of it was styled by Yoichi Sato, and 3 decades later, it remains one of the most aesthetically resolved sports car designs to come out of that era, still referenced constantly in design circles today. But the very engineering sophistication that made the FD special is also what undid it commercially. The sequential turbocharger system, while technically brilliant, proved genuinely difficult for owners and mechanics unfamiliar with its specific demands to maintain correctly. Cooling requirements were significant and unforgiving. Cars that weren't serviced with real attention to those specifics developed reliability problems the engine's fundamental design simply couldn't absorb. The rotary itself added its own layer of complexity on top of that always thirstier, relative to its displacement than a comparable piston engine, and requiring apex seal service at intervals conventional engines never needed. Mazda discontinued the RX-7 in 2002 with no direct successor. To this day, no manufacturer has produced another twin sequential turbocharged rotary road car. The engine concept Mazda stayed committed to for 35 years remains, to this day, completely unique in production automotive history. Nobody else has ever built one. Number 4. 1990 Mitsubishi 3000 GT VR4. The VR4 arrived in 1990 carrying a specification sheet that, assembled into a single production vehicle, had genuinely no precedent at its price point anywhere in the world. The foundation of that specification was a twin turbocharged 3.0-liter V6 producing 300 horsepower, delivered through a full-time all-wheel drive system at a moment when most performance cars in the world were still committed to rear-wheel drive on principle, treating it as a non-negotiable part of what a real performance car had to be. Layered on top of that was four-wheel steering, turning the rear wheels in coordinated response to front steering input at varying vehicle speeds. Both of those features on their own would have been notable in 1990. Neither of them was actually what set the VR4 apart most completely from everything else on sale. That distinction belonged to its active aerodynamic system. The VR4 used electronically adjustable front and rear spoilers that changed angle automatically based on vehicle speed, increasing downforce as speed climbed, and reducing drag again as it dropped, with zero input required from the driver. This wasn't a driver-selectable sport mode gimmick, and it wasn't a marketing concept dressed up with technical sounding language. It was a genuinely functioning system, operating continuously and transparently in the background, doing exactly what active aerodynamics are supposed to do, constantly optimizing the car's relationship with the air around it as conditions changed in real time. Nothing at this price point, from any manufacturer, was doing that in 1990. The VR4 wasn't without real drawbacks, and they were direct consequences of carrying all that technology. It was heavy, and that weight undercut the handling precision its specification sheet implied it should have delivered. What the VR4 demonstrated imperfectly in execution, but unambiguously in intent, was that active aerodynamics belonged on road cars, and that Japanese manufacturers were prepared to implement them before any European competitor at any comparable price point had done so. Number 5. 1992 Subaru SVX. The SVX is the least remembered car on this list. Its obscurity has almost nothing to do with its engineering merit. It was designed by Giorgetto Giugiaro at Italdesign, and developed by Subaru as a genuine grand tourer, not a sports car chasing lap times, but a car built for sustained high-speed comfort and refinement. It arrived with a 230 horsepower flat-six engine, a sophisticated all-wheel drive system, and a drag coefficient of just 0.29, a figure that matched or beat dedicated sports cars from manufacturers who treated aerodynamic efficiency as a core part of their brand identity. Subaru, a company not particularly known at the time for grand touring cars, quietly out-engineered several of them on this specific metric. The SVX's single most distinctive feature was its aircraft-influenced window design. The door glass was split into two sections. The lower portion was fixed in place permanently. Only the upper section could actually open. This created a window within a window effect that reduced wind noise at speed and contributed directly to the car's exceptional aerodynamic performance. This wasn't a styling flourish included for visual distinction, it was a structural aerodynamic solution that happened to also look unlike anything else on the road. What undermined SVX wasn't its engineering, it was a single product decision made somewhere in Subaru's planning process. The only gearbox available throughout the car's entire production run was a 4-speed automatic. No manual option was ever offered despite a chassis, an engine, and a design language that all promised something more engaging. That one decision cut the SVX off from every buyer who wanted genuine driver engagement to go along with the refinement it delivered everywhere else. Subaru discontinued the SVX in 1996 after modest sales. It has never been fully reassessed by the market or the enthusiast community at the level its actual engineering justifies. A car with Giugiaro styling, a drag coefficient competitive with dedicated sports cars, a sophisticated odd system, and a flat-6 engine deserved more consideration than an automatic-only drivetrain ultimately allowed it to receive. Number 6. 1997 Toyota Prius. Toyota's development of the Prius began in 1993 under an internal engineering initiative called Project G21. The stated objective of that program was specific and difficult. Produce a car with fuel efficiency double that of conventional vehicles using technology that could actually be manufactured at production scale and sold to ordinary buyers at a price they would realistically pay. Not a concept car. Not a limited-run technology demonstrator. A real product for a mass market. 4 years later, in December 1997, Toyota launched the result in Japan, the world's first mass-produced hybrid vehicle. The Prius combined a 1.5-liter gasoline engine with an electric motor and a nickel-metal hydride battery pack in a power split arrangement engineered to do 3 things simultaneously. Let the electric motor drive the car independently at low speeds, let the gasoline engine operate at its most thermally efficient point in the RPM range rather than being forced to idle or lug, and use regenerative braking to recover energy that conventional cars simply discarded as heat every time the driver touched the brake pedal. The Prius was not received as a revelation in 1997. Quite the opposite. It was met with real skepticism from consumers who weren't sure about its long-term reliability, from automotive media who genuinely didn't know whether hybrid technology represented meaningful progress or just expensive complication, and from competing manufacturers, most of whom looked at the technology and concluded it was too costly and too complex to pursue seriously at the time. Every one of those manufacturers who reached that conclusion in the late 1990s eventually spent billions of dollars developing their own hybrid systems anyway after the Prius spent a decade in production, sold hundreds of thousands of units, and proved definitively that the technology worked, that buyers actually wanted it, and that the future Toyota had identified back in 1993 was arriving faster than almost anyone in the industry had anticipated. The Prius wasn't just ahead of its time in engineering terms. It was ahead in market terms, in cultural terms, and in regulatory terms, arriving before the broader conversation about automotive emissions had even fully formed, and going on to help define the terms of that conversation for years afterward. If you're enjoying this breakdown, drop a like right now. It genuinely helps this video reach more people who care about this kind of engineering history. 2 cars left. Let's finish the list. Number 7. 1994 Honda Accord with active noise cancellation. Active noise cancellation, the same core technology now found in premium headphones and increasingly in premium vehicle cabins, works on a simple principle. A microphone detects unwanted sound, and the system generates an opposing sound wave to neutralize it before it ever reaches the listener's ear. Honda implemented this technology in the cabin of the 1994 Accord, not a flagship, not a limited edition trim. The regular mainstream Accord that ordinary families were buying by the hundreds of thousands. Microphones in the cabin detected low-frequency exhaust and engine noise. Speakers then generated the canceling signal in real time. The measurable result was a quieter interior than passive sound insulation alone could ever achieve, and Honda got there without the weight penalty that comes from piling in additional physical sound deadening material. That weight saving, in turn, contributed to fuel efficiency without costing the car anything in refinement. This is worth sitting with for a moment. This was not a luxury flagship built to showcase what a manufacturer's engineering division was capable of. It was not a halo car produced in small numbers to generate headlines. It was a mainstream family sedan, sold to ordinary buyers who overwhelmingly had no idea the technology was even present, because its only real evidence was an interior that was quieter than they expected it to be. The broader automotive industry adopted active noise cancellation progressively through the 2000s and into the 2010s. Today, it's found across a wide range of vehicles at very different price points, often marketed as a premium technology feature. Honda had a working version of it in a mainstream family sedan in 1994, roughly 2 full decades before the rest of the industry treated it as standard. Number 8. 1985 Nissan 300ZX Z31 with digital instrumentation. Long before digital instrument clusters became something manufacturers marketed as proof of their forward-thinking approach to the driving experience, Nissan was already offering them in the Z31 Generation 300ZX, as early as 1984 in the Japanese domestic market and 1985 in export markets. The digital dashboard replaced conventional analog gauges with an electronically rendered display, showing speed, RPM, fuel level, coolant temperature, and warning indicators in a format that contemporary buyers found either impressively futuristic or genuinely difficult to read at a glance, depending entirely on personal preference. It also came with a trip computer and onboard system calculating and displaying fuel consumption, estimated range, and elapsed journey time, at a moment when the overwhelming majority of production cars on the road had zero onboard computing capability of any kind. The Z31's digital instrumentation was, put simply, ahead of where the market was actually prepared to accept it. Subsequent generations of the 300ZX moved back to conventional analog gauge presentations once buyer feedback made it clear the digital display wasn't universally appreciated. But the direction the technology pointed toward was correct, even if the timing was early. The industry moved entirely toward digital and fully configurable instrument displays over the following 2 decades. The Z31 demonstrated that exact direction a full 20 years before it became standard practice across the industry. The engineers working on these cars were given briefs that prioritized technical achievement. Japan's economic environment during its bubble period provided the resources to pursue those briefs without the cost constraints that typically govern automotive development programs. Several of these cars failed commercially despite succeeding technically. The RX-7 was too demanding for many buyers. The SVX was undermined by its transmission. The 3000 GT VR4 was too heavy to fully deliver on its specification. The first Prius was met with deep skepticism from consumers and the industry alike. None of those commercial outcomes changed what these cars represented, or what they contributed to the direction the industry subsequently took. The aluminum architecture Honda pioneered in the NSX influenced the construction of the McLaren F1 and eventually found its way into volume production. The hybrid system Toyota developed for the Prius became the foundation for an industry-wide transition still unfolding today. The odd and 4-wheel steering systems Nissan and Mitsubishi deployed in production cars at accessible price points became defining features of performance vehicles globally. Active noise cancellation went from a 1994 Accord feature to a standard expectation in premium cabins. Digital instrument clusters went from a 1985 Z31 option to the default configuration in virtually every new vehicle sold. Japan did not simply build advanced cars during this period. It built cars that showed the rest of the industry where it was going, and then waited, sometimes for decades, for everyone else to arrive. Hit subscribe if you want more of this. Drop in the comments which car on this list you think had the most lasting impact on the industry. I'll read them. I'll see you on the next one.